Hello, everybody, and welcome to this second webinar about Frenetic AI. Hello to everyone. Good morning, good afternoon to everybody around the world. I only want to remember you that if you are joining this webinar with free email as Gmail, Outlook, and you want to be a beta tester for our new tool Frenetic AI, you have to join to the waitlist with your professional email to have access. That's all from me. Chema, it's all yours.
Okay, thank you. Okay, so thank you very much, Ellie. I'm glad that we another week here with all of you to start this demo about our new technology, this new feature for Frenetic simulator, what we call Frenetic AI. So let me share my screen. As always, we will start just checking the agenda. So what we are going to do today is review the simulator. The simulator is basically the technology that we put in the market a few years ago, and is the base of everything. Is our more accuracy tool for designing magnetics, transformers, inductors for any power supply. Then we will review a little bit about what are we building with Frenetic AI, and then we will do the demonstration with the magnetic design. Together with me here, I have also Emmy, who can help us with more information. So hi, Emmy, how are you?
Hi, Chema. Hi, everyone. Thank you a lot for joining us in this presentation that we are going to show what we have been working to put in your hands, our technology and all of our knowledge. And well, after the demo that Chema will show us, we are going to grant access to all of you with your corporate emails to the tool. So be aware of all these things, and what at the end of the session we will take again, and you will have your credentials to access and test our technology.
Okay, so thank you, Emmy. Let's move on. Well, let's explain first what is Frenetic Simulator. Most of you already know that Frenetic is a company that has a software for, is an online software for designing transformers and inductors, very close to the simulation of the power electronics. So for giving you a more, let's say, accurate idea about what do we have here, I just going to explain you a few cases. And here in this QR code, you have access directly to request a demo for you or your company. So some of these use cases could be like, imagine that you are building CLLC transformer 3.3 kilowatts for a wide range of operation. So this is one of the samples that one of our customers shared with us. So they basically just not only design the transformer, but also they run simulations in all the operating points that are needed to build a report for the customer. But in some cases, some of our customers have shared with us projects where they are simulating existing design, an existing inductor that is already built, but they don't know what is the saturation, or they don't know the losses, the temperature for that specific case. So then this is another typical use case. Other typical cases for resonant converters where you need to calculate all the waveforms. So if you want to have a very accurate calculation of the losses, it's very common that you need to have a kind of waveform generator. So at the end, Frenetic can generate all the waveform for all your cases. So if you want to compare the transformer for different topologies, this is the best solution. Also, if you are working with very, let's say, low frequency materials like nanocrystalline or amorpho, also you can use our technology because you can find them there. And of course, that one of them might, let's say, one of the features that I consider most interesting is when you are designing a transformer and inductor together. If you want to put an transformer and you want to get the leakage inductance as a resonant, resonant, use the leakage inductance as a resonant part, you can use our algorithm for that. The reason is that this algorithm is going to look for the specific leakage inductance that is going to be equal to the resonance that you are looking for. And if it's possible, if it's feasible, it's going to suggest you the complete magnetic that is going to work under the thermal conditions you specify, but also having this leakage inductance. And finally, string cases. When you are working in high isolation requirements, like we just finished a 50 kilovolts designs for oil and gas application. So this is also a very good application. So moving on with Frenetic AI. So the reason that we started creating Frenetic AI is that we have seen that the use of large technologies in terms of AI can help us to give access to our modeling and our technology to more people. That means that we are able to accelerate a lot of complete tasks for the engineers. Some of these tasks could be like create LTSpice files, run simulations for magnetics, look for solutions in the market. So complete tasks that the electrical engineers need to do every day in their job, try to automate the complete task. So this is the main goal of Frenetic AI. And today, for this demo of magnetic design, we will follow the same schedule that the last week. So with some basic inputs, we will generate some circuits, and then with that circuits, we are going to design the magnetic, and then we will jump to Frenetic simulator to go to more detail. So now I'm going to jump directly to the demonstration. Okay, so what you can see in the screen is the case that one of the cases I'm going to use. So this is an application of from Texas Instrument, where basically it's a phase shift full bridge, 600 watt. Here we have the specifications. The input is from 370 volts to 410, and the output is 12 volts. And they choose 200 kilohertz of switching frequency. So then what I'm going to do is going directly to our, let's say, the application that you get access, or you already have access because you came last week, or you will receive access today. And I just need to type here the inputs. This is the input voltage, so I'm going to type 370 volts and 410 volts. And in the output, I'm going to type 12 volts, and the power level is 600 watt. Since I want the system to be forced to use 200 kilohertz, I'm going to write here 200 kilohertz. And I'm going to choose the full bridge phase shift topology and confirm input data. So this has been very fast because basically we have a cache system. So basically I just tested before, and what we can see is that here you can see the output of the system. So basically it's like all the parameters of the circuit. We can see the switching frequency, the output current, the tune ratio, let's say the data cycle for each case, the phase shift that you need to apply, magnetizing inductance, output inductance, and the ripple. So before generating the magnetic, I'm going to generate the LTSpice. The LTSpice is here, is going to help us to verify also the whole simulation, and you will see how fast this could be. In the meantime, while this LTSpice is generated, I'm going to run here the second case for today, because it can take a few minutes. So the second case is going to be an inductor, boost inductor, 100 watts for a boost. So then I'm going to run here, inductor. Again, I have in the cache, you can see that I have generated this very fast. And now I'm going to ask for the magnetic directly. We are not going to ask for the LTSpice here. So this is going to be running, and I'm here generating the LTSpice. So let's see how we generate that. And I'm sorry. And something that you will see now with okay, here we have already generated the magnetic for the inductor that is going faster. So what I'm going to do here, just to continue, is that you can see that this is the magnetic for this, let's say the inductor. It is an ER18 core, 3C97. You can see the core losses, winding losses, temperature. And if you're a user of Frenetic Simulator, you can just type here your account and save. And then if we go to Frenetic Simulator here, we update our list of projects, when we have seen that we have created that one. So now this project that is here called, well, Blender, whatever, we have already here the design generated, where we have all the information for the core, for the winding and everything. So now you can continue the design or the simulation of this project here, and even adding more information like, okay, the let's say the output current for this case, or the output power, and then also you can come here to add more operating points, what means that you can play to see how would be the different losses for different conditions. For example, in this case, I just decrease the temperature, let's say the current to half, and I'm going to test the system until different switching conditions, let's say what's happened at 400 kilohertz. For that one. And I can finally have a summary of a report of all the simulations. So you can see I have simulated 3 operating conditions, different voltage levels, and let's say different current levels and different frequency. And I have here all the analysis of the core losses, winding losses for each of the cases. Let's come back to see if we are able to generate. Okay, this is taking more time, so let me take another simulation to run the transformer. And see the magnetics of the system. Okay. Now I'm going to ask for the magnetics. Usually this can take up to 1 or 2 minutes. So it's something that we need to wait a little bit. And if you are using the, if you have already access, before you didn't have enable this button here, but suggest magnetic, now you will have access. And if you're a Frenetic, you have a Frenetic account, also you can open up. Let's see. Here we already have the magnetic for this full bridge phase shift. So as you can see, the system have generated 2 magnetics. One is a transformer, and the other one is the inductor, the output inductor. So again, we can come here and just type our account of Frenetic, and then here again, same thing. And if we go to our application of Frenetic, our list of designs, here we have all the information. Let's say we have the transformer in this case and the inductor in the other case. So we can here and we can see the whole details of this transformer, where we can see the leakage inductance here, accuracy higher than 90%. We can see the this distribution of the losses, and we can change everything. We can go to all the details to change this design. I think that I have covered everything. Emmy, Ellie, do you think that do you want to add anything, or do you want me to show anything else that you think I'm missing?
No, it's okay. We cover all the scenario, and I'm answering one of the questions that are on the chat. Now we are going to send the credential to everyone that registered to event with a corporate email, so you can access inside this platform. Just you to know, as you mentioned, this is our first version. We are improving the product and with many releases of different use cases and evolution of the platform in the coming weeks. So take into account that after you put your input and you select one of the options, it will take some time. It's better to wait a bit until you get the result. You will get the result by sure. And just to take in account that when you enter inside the platform, if you refresh the web page or you press F5, you will need to log in again. So take care of not doing this. So just follow or delete the input and you can run it again. And now we are
Yeah,
starting.
that's a good point. If you want to start again, you don't need to reload. Actually, if you reload, you will log out. So you can just come here and just change the inputs. So you come here and say like I don't know, like 202 volts and then 60 bats, and then let's say I want flyback with a specific um, specific fly a specific magnetizing inductance. So I can just confirm the data, and this system is going to work again. So in this version, it's going to be like an historic. So you will get here keeping all the information. So you run several times, you will keep here the story of all your calculations. We are not storing any of this information. We are not using this for training because we are not training anything. And all this data here is basically just not stored in any place or anything. This is just our first version. So we just want to put it in your hands for receiving your feedback. And this is a very important thing, that is the feedback. So here you have a box. So anything that can, anything that you want to write, anything that you want to let us know, just type it here and send us the feedback. Um, I see somebody raise a hand. You just can type your question in the Q&A. So let's go to the Q&A part. Well, before the Q&A, I remember we have some news for next week.
Just to comment that we are sending the credentials to the emails. So you have a user that is the same as your email and a password that is generated for you.
By the way, you still can use this feature that we presented last week. So just for all of you that didn't come last week, I'm going to explain you how this is working. It's very easy. So once you click in the generate LT spice, for example, for this flyback, I just create it here. It's generated a design, and then you can download the LT spice. So you download the LT spice, you come to your browser, you just unzip the project, open LT spice, and you can open directly that file. Sorry, LT spice. So you have here the file, click and run, and we automatically have created the simulation file for you to see the most relevant waveforms. In this case, the output voltage, the voltage in the switch, current in the transformer, and primary and secondary, and also the voltage in the output and in the load. So this is, as you can see, you don't need to be an expert in LTS spice. It's just that just click run and that's all. If you want to make modifications, here you go to the details, and all these parameters are you can edit all of them, so you can change whatever you want. So coming back to the last point of the presentation, so next week is going to be our last, I think it's our last demo for the version 1 of Frenetic AI, and it's going to be about planar magnetic design. So this is the QR code. You will receive let's say, also the invitation. But if you want to register today, this is just a QR code for that presentation where we will do the same than today, but for planar magnetic design. And everybody that came here will receive access during the presentation to test it by themselves. So that's all for today. Let's try to check if there is any question not answered. Amy, do you need to add? Do you want to add anything? You're muted.
Sorry. Yes, we already have sent the invitation, and also we are sharing the link for the next week event. And we have a couple of questions, if you want to check, Chema, that are related to particular cases. Even we are going to send a recording of this demo to all the registered people.
Okay, I see that there's a question is, can we import LT-SPICE files to Frenetic? So in Frenetic Simulator, you can import the simulation file to run a simulation. So if you already have a simulation or LT-SPICE, or you create an LT-SPICE, then with the waveforms of that LT-SPICE, you can simulate a magnetic. So I hope that this can help you to understand that. So thank you, say this one other. Somebody is thinking that maybe take time because we open a lot of designs. Yeah, it could be. Yeah, we are giving access. Somebody is asking for one pulse, one earth. I think that if you are looking for, let's say, a case where you need to build a kind of pulse generator of one earth, I don't think that this is going to be this kind of high frequency power supplies, but maybe you write us an email, we can help you with that, okay? I think that we are running out of time. Okay, last question. Can I get the design procedure in PDF format? So I think that already Amy has answered this. We will share this video so you can see the video step by step. I think that we are building also some small videos just for giving kind of instructions for the basics. So we will publish those videos as soon as possible. PDF design procedure could be interesting. So maybe we will consider to have a PDF for following a step by step. Maybe it's easier than a video. So thank you for the suggestion, Rajesh. Somebody is asking for if the email on the password is the same for Frenetic AI than Frenetic Simulator. If you are a customer, yes, but if not, it's not going to work because Frenetic Simulator is a tool for customers, so it's not a free tool, and they have access. I mean, the people that have a license or an account, they have access, but not. It's not an open tool. So if you want to get access and you are, for example, for university, you have specific prices and everything. So we can help you to get exactly what you need. And yeah, I think that that's all for today. Ellie, Emi, maybe you want to add something or say goodbye to our audience?
No, thank you a lot for the time. I think that it's really important that you test our tool. And what we will be in touch for your feedback and the way to improve it, and keep in touch because we have many use cases to share with you. Ellie?
Yeah, and don't forget to join our next webinar about how to design planners.
Okay, so well, thank you very much, everybody, and see you next week.
Thank you.
See you.